Cool. Hello, everyone, and welcome to Building a Kotlin Multiplatform Library in 10 minutes. Why not? Now, before we get started, I do have a viewer discretion that I have to give out. There will be live code generation ahead. This can be quite scary, so if you're of the faint-hearted, please, you may leave now. Otherwise, I can't be held accountable. So, just discretion's out of the way. Who am I? I'm Zachary Powell. I've been an Android developer for far too long, started in 2009. I then more recently moved into developer advocacy and was a senior Android developer advocate for a while, and then more recently I've turned to the dark side and become a manager, but I do still do a lot of Android stuff in my free time. I can't escape it. And if you want to find me anywhere online, I'm under Dev with Zachary. So I kind of have to give them a bit of a plug because they've paid for me to be here. The company that I currently work for as a manager within developer relations is a company called Vonage. We are now part of Ericsson. And in general, we do communication APIs and more recently also network APIs, which expose functionality of the 5G networks. But in general, I spend my days doing a lot of stuff with APIs. And as an Android developer alongside lots of API stuff, we all use a lot of libraries. The Android SDK itself is a library that sits on top of either Java or Kotlin or the JVM and exposes stuff to us that the Android operating system allows. Other things like when we're doing testing, we almost certainly are using some sort of library or framework to do that testing. We're not manually writing if statements to check values. We're doing something with frameworks. If we want to even start touching dependency injection, again, you're going to use a library to do that. You're not completely insane. Networking as well is another one where we're going to probably be doing lots of libraries. We don't make raw HTTP requests. That's quite painful. And so many other things. We use a lot of libraries as Android developers. And alongside those libraries, we use a lot of APIs, or application programming interfaces. We might consume two different types of APIs. Either they might be third-party APIs from other companies, perhaps Vonage, but in general, some way to enhance your app. Maybe you're using an API to pull down data for your app, plug for the last presentation, and getting TV information. But there's lots of APIs out there that we can use for different things from third parties. We'll also have internal APIs. Most of our applications are going to have some sort of backend. There aren't many use cases these days that are just purely an app. You're going to have something happening server-side, and you're going to need a way for your app to communicate with that server, so you're going to build an internal API in some respect. And as we might learn, especially with the internal APIs, consuming them manually can really, really suck. It can really be a slow process. They'll probably lack a library because the back-end developers won't have built you a library. So unless you've got a team that's building libraries for you, that's not going to happen. There's not going to be a library there to use. The API is probably missing documentation. The server-side team might have said, oh, yeah, it works like this. You just put these parameters in, hit this URL, and you get your stuff out. And actually, the format that they've said it's returned in is completely different. The parameters are case-sensitive when they said they weren't, and lots of other different things are completely different to what someone on that team has previously said. There's no good documentation. And the result is really time-consuming. You've got to do a lot of your own testing against these APIs to figure out how do they actually work, what do you actually need to do to make it give you the information you need. And ultimately, that's a lot of ambiguity between the people that are creating the API. Maybe they decide to do a new feature and it breaks everything that you've been doing previously because they didn't realize that's how you were using it, and so on and so forth. There's no good parity between the two teams. So let's fix that with generating libraries. So we're going to do that, but how are we going to go about that? Well, we have to talk about something called OpenAPI and the OpenAPI initiative. No, this is not OpenAI. We're not talking about OpenAI. We're talking about OpenAPI. And if I say OpenAI at some point, I'm very sorry. I'm dyslexic. We'll blame it on that. So quick show of hands. Has anyone heard of OpenAPI? That's a good start. There's lots of people to teach. Out of those people that have heard of it, who uses OpenAPI or the OpenAPI specification? I see one. Good. Lots of people to convert. The more simple question, what is OpenAPI? From their website is this nice, very wordy answer. It's concise, but I'm not going to read it out. Again, dyslexic. But essentially, OpenAPI and the OpenAPI Alliance have built a specification of how you go about defining an API in a language-agnostic way that basically can act as a document that is the source of truth on what an API is, what it does, what it expects to be sent, what it expects to return, all those sorts of really important pieces of information. And it does this using OpenAPI documents, which basically are objects that break down your API definition, lots of different objects for lots of different purposes. Things like contact information. If you've got an issue with your API, who do you actually need to contact? Even internally, well, who actually wrote this API? Who's actually responsible for it? Who can we blame when it goes wrong? Things like server information. Where do I actually need to point my client to get the API information? The different endpoints that the API make up, parameters, things that you can expect return, things you can expect to send, all that sort of stuff. Everything you could possibly think of is defined in this specification. And the specification is written in two ways. You can either use JSON, and this is an example of some metadata that you might have for your sample pet store app API. Or, if you're a complete psychopath, you can use YAML. I really recommend not doing that, but that's my own personal preference. Point is, both exist, both are fully supported. Maybe the tooling that you use has a preference for one or the other, so they're both available, they can both be used. But why? Why do we want to create this specification? Sounds like an awful lot of extra work. You're kind of probably in an internal API, most of them are never touched. Once it's built, it works, leave it alone. Why do you want to do this? Well, the main thing is during the building phase. Defining an API, using OpenAPI to define an API contract means that those that are creating the API and those that are consuming it are in complete agreement about what that API should look like. Those that are consuming it, they don't actually care how it's been implemented. They don't care about the code behind the API. They just care that, well, as long as I hit this endpoint with this information, I'm going to get this information back. Those that are creating the API don't really care what the person is using it for or how they're using it. They just care that this is what it's expected to look like. So having a contract from that very start gives you a complete understanding of how this is going to work, even before the code's been written. It also means that the client side you can use that API spec to start building out their side in parallel with the server side being built. There's no dependency on, we've got to wait till the API is done. We know what it's going to look like. But for me, the main reason for using OpenAPI specifically, and not just some internal spec that you come up with as a team, is the tooling. There is a massive amount of tooling available specifically that consumes OpenAPI specs. You can use it to automatically generate documentation. So you can pass it in your OpenAPI spec, and it will then create a nice, user-friendly documentation page. So if you are shipping an API that you want third parties to consume, well, you've just saved yourself a job because you now have an automated way of keeping the documentation up to date. As soon as something changes in the spec, you can update your docs. Everyone's happy. You can also use it for mocking. So again, when maybe the API isn't actually ready yet, or you're just not ready to start hitting the API, you can use the spec to mock. And there are lots of tools out there that will help you with that by consuming an API spec. There's also really some great security tools out there. So you can use these tools, you can give it your API spec, and then these tools can go off and start trying to look for vulnerabilities in your API. It can do pen testing, it can do all these sorts of things automatically because you've just instantly given it all the information it needs to be able to do that. And then more generally, testing as well. On the server side, maybe not so much for us because we'd probably just be mocking it, but on the server side, you can definitely test to make sure that the code you've written is always correct to the spec. And then if it's not, you know you either need to update the spec or you need to update your code. But either way, you've got a way of building a testing framework for your API. But the thing that we're particularly interested in today is code generation, something that there are a few tools that are available to do that, and we're going to look into today. But there is a website, openapi.tools, confusingly not affiliated with the OpenAPI initiative, but still it's a very useful website that shows a huge list of all the different tools that are available that use OpenAPI in some way. So we're going to test out some code generation. We're going to look at why this might be a good thing to do, or not. And we need an API to do that. So naturally, I'm going to pick one of my own APIs, and we're going to use the Vonage SMS API to be able to send a text message through an API. The reason for using this particularly is it's a very simple API. There's only one endpoint. It's quite concise. It works with the code generation tool. And we have a full API spec for it. We have full OpenAPI specs for all our APIs, but some of them are much more complex than others. So we'll stick with a simple one. And this is just kind of a snippet, again, of the actual OpenAPI spec. Note it's using JSON, not YAML. And this shows you the path that we are going to be hitting. We can pass in a parameter format that will either be JSON or XML for the response, and some more gumph about the API endpoint. But that's generally what these things kind of start to look like. So the tool we're going to be using is OpenAPI Generator. Again, a very confusingly named project that has no affiliation whatsoever with the OpenAPI initiative. It's a completely independent open source project, but nonetheless, it is massive. It supports a huge range of languages and frameworks that you can generate code in. So if you really need to release a library for NIM, I don't actually know what NIM is, but if you really needed to release a library for it, you could use this. But obviously, there's one on there that we're particularly interested in. You might have spotted Android. It's not that one. It's Kotlin. Just because basically the Android client is more dated. Basically, all these clients are supported. You can add your own clients if you want to. So they've kind of merged everything into Kotlin, which I think makes a lot of sense. And we're going to be looking at Kotlin Multiplatform for that. So this is a command line tool, so we're going to be using the command line. And another reason I like this tool is it in itself is a Java application. So you just download the jar file, and then you can call it. You use the command generate. You pass in your OpenAPI spec, in this case our JSON file. You tell it which generator you're going to use. Again, huge list on the website. There's also a huge list of server-side generators as well. We're not getting into that today, but there's lots there. We're going to use Kotlin. And then we need to add in some extra properties. These will depend on which generator you're using, but for Kotlin specifically, we're going to tell it to use the multi-platform library, because we're going to generate a multi-platform library. And we also need to just set the date library used. So because we are building a multi-platform library, we're going to use the datetime library that's compatible with that. Again, there's a wiki page that shows you all the information. There are hundreds of configuration options on things that you can do with this. If you're targeting specific things like just the JVM, you've got other options, or you're just targeting Android. But here, we're keeping it pretty simple. So that's our command. That's it. So it's time to generate the code. and this is where I hope it works. So we'll come over to the command line. We will have our command. We're in a folder called SDK, and we're going to generate it, and it worked. That's nice. It lets us gives us lots of information by standout what it's been writing. There are a few errors that get generated. Essentially, there are some things in the schema that it doesn't like. Again, because it's such a massive project, that there's different things that aren't necessarily supported in every generator. Doesn't particularly affect us for this sample. And of course, it's open source. So if you wanted to go fix those errors, please do. But the point is that it has generated it, and it has given us that nice message at the bottom. So we can head over into the code that's been generated. So this is the library here. First things first, the generator is still using Kotlin 1.9. Well, Kotlin 1 is dead to me, so we're going to switch over to 2. And not just because that's what my sample project's in, honest. So we're going to just do that, and we're going to let Gradle do its thing. But this is all the code that it generates. It also very nicely generates documentation for us as well. So we get a very nice overview README that gives you specific information about what's been generated, what level of Kotlin's required, how you can build the library, different implementation notes, and then specifically it will document the different endpoints, the models that it's generated, the authorization that you need, all that sort of stuff. It's all generated for us. Now, as I sort of said, there's only one endpoint on this API, so we can go in and we can look at the default API. Again, you can change the name of it in configuration parameters. And we have this method called send an SMS. I wonder what that does. And it gives you but most importantly, it does give you an example. Now, unfortunately, it also copies all the comments that are against each property from the OpenAPI spec. So it already gives you a lot more information than you actually need, but it is all there. It is also quite, it is verbose. It gives you everything that is in the spec. So the more information you put in, the more information you get out. So that's the documentation side. And then the actual API itself is, again, it's one Kotlin file at the moment with just our send SMS function. It has thankfully remembered to leave everything optional that is actually optional in the API. I was a bit worried it was going to make us do everything, but it doesn't. And then it builds the parameters, it goes through and does all that sort of fun stuff. There is also a lot of infrastructure that gets generated for you, HTTP responses, the app client itself. You can also select, when you're generating the code, you can select what HTTP library you want to use, all those sorts of things. So you can basically make sure that it fits into whatever stack you already have. We're not going to go through all this. The point is this is all very boring boilerplate code, but it's done it for us, which is nice. So we're going to give this a go. We're going to use this and see what it's like. So if we head over to my absolutely amazing multi-platform application, we can see that we're just importing the project from the SDK library, and then we're just using it in our project there. Our app is a very simple compose app that is essentially going to display a text string. It's going to either display an error message, or it's going to display the response from our SMS call. We have SMS here, which is just making use of that API that we've created. We're going to pass in some text. So here we have text string that we can pass in. And then here we're just adding onto it sent from platform, so we can prove that it's on whatever platform it's on, because why not? And then we're passing in our API key, our from phone number, our to phone number, and our API secret, which I'm sure a lot of people are already freaking out about, because you should not do this on the client side. And again, this API should not be used on the client side, because you will expose your secrets. So this is just for testing purposes only. Please do this on the server side and have your own API call to get there. But yes, we're then just taking the API instance, sending the SMS, and we are going to either send back the error, if one happens, or we are going to send back this text string that we've generated. So let's see if this works. So to prove that it is, in fact, a Kotlin multi-platform, we're going to launch it on iOS. So there we go. We've got our text saying "Hello from Joy-Con," and there you go. I've received the text message. It actually worked. That's nice. So there we go. I've received a text message on my actual phone saying "Hello from Joy-Con Lisbon," sent from iOS 17, and that's sent from the iOS emulator. So there you go. It worked. Again, don't use this in production. So we've been able to very quickly generate a library from an OpenAPI spec. We've been able to build a sample very quickly, and we've been able to send ourselves a message, i.e. make use of that API. But why not? Why shouldn't we? And this was my artistic interpretation of why not. It's the not version of the why meme. Okay. So why shouldn't we do this? Why is this a problem? And I'm sure some people are already starting to think of reasons why this is a problem just from the little bit of code that we have seen. So one of the biggest things, which I touched on early on, was that if your OpenAPI spec is incomplete or it's too complex, there's lots going on, it uses lots of features of the specification that the generator doesn't necessarily support, the code that it generates might not be what you expect, or it might just not generate anything at all, and it will just error out. So, for real-world complex APIs, this isn't necessarily to a point where you can use it, you can just hit a button, there's your library generated, ship the library. You can't necessarily do that. It's also purely a one-to-one mapping. Whatever you put in with the spec is what you're going to get out as code, which is fine, but that kind of defeats the point of a library. A library shouldn't just be a one-to-one mapping of an API. A library should make using that API significantly easier. It should add in things like, should add things like additional business logic, helper functions, things like, for example, maybe there is an instance where you need to make 3 or 4 API calls to complete an action. Well, the library should have a function that just does that for you and then returns the result. Whereas, obviously, with our generated library, you would have to know to use each API endpoint. So that's not particularly helpful in those sorts of more complex scenarios. It's also not necessary, again, because of the business logic side, where you won't be able to make an API call based on the data that you've received. There's no processing of that data in the library. There's no additional kind of help there. It's a little bit kind of one-to-one mapping, dry. It's a bit boring. But it is a really good starting point. I really hope that at least a few people are convinced to start looking at this because, A, creating the OpenAPI spec helps everyone. It's a really good thing to do for internal APIs. I would dare say it's almost essential for external APIs. You should be able to provide a developer with a direct documentation of what everything does. And doing it in a format that other programs can consume, it just makes it so much easier. But the code generation side, building the library, it builds a lot of boilerplate code for you. There's a lot of stuff there that's just annoying to put together. And if you get generated, if it generates the library for you, and you start looking at it and go, oh, that's wrong. No, that's not right. I don't like that. That tells you what you should then be improving on. It's one of the ways that I make use of AI. AI is great at telling you the wrong thing, so you then know, oh, yeah, actually, I meant this. This is where I need to go. Code generators like this, stupid code generators, are really good at showing you what is wrong so that you can then improve on it. So if you're really stuck with, oh, where do I start? Have a look at this. But it is proof that, without a doubt, handmade SDKs aren't going anywhere. This isn't everyone can now stop making SDKs. We can just use code generation, and we haven't got to worry about it. really is the fact that when you build a library, build an SDK, it's those helper functions, that business logic, that really makes it a useful tool, as opposed to just kind of a wrapped HTTP library. So definitely, we're not going anywhere with kind of our SDKs anytime soon. And on that kind of segue, we do have a new Kotlin server SDK available. It's not officially released yet, but it's on GitHub. So if you want to check it out, please do. I was here last year, and I was talking about our multi-platform client SDKs. So you can now do everything in Kotlin, which is what I like. So do go check that out, please, if you can. And that is everything. I've left some time if we have any questions, but thank you very much. If you would like to check out my links and stuff, scan the obnoxiously large QR code. And yeah, thank you very much.